Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the named reactions involving aldehydes and ketones. Here I am going to discuss in detail about the 8 named reactions which generally includes Clemency reduction, Wolff-Kishner reduction, Zarrow reaction, aldol condensation, Rosemann reduction, Itard reaction, Gutterman-Koch reaction, and Stephen's reduction. Coming to the Clemency reduction, it involves the conversion of carbonyl group into methylene group. And coming to the Wolff-Kishner reduction, it also involves the conversion of carbonyl group into methylene group. The only difference between the Clemency reduction and Wolff-Kishner reduction is, in the case of Clemency reduction, the carbonyl group is converted into methylene group in the presence of amalgamated zinc and acid. Coming to the Wolff-Kishner reduction, here the reduction takes place in the presence of hydrogen supported by the alkali. Now coming to the Zarrow reaction, it involves the conversion of aldehyde into alcohol and acid. That means here two aldehydes will be taken. One undergoes oxidation and the other one undergoes reduction. Coming to the aldol condensation, here aldol condensation involves self-condensation of aldehydes which results in the formation of beta hydroxyaldehyde. And moving to the Rosemann reduction, it involves the preparation of aldehydes from acid halides. Similarly, Itard reaction involves the preparation of benzaldehyde from the toluene. Coming to the Gutterman-Koch reaction, it involves the conversion of benzene into benzaldehyde. And coming to the Stephen's reduction, it involves the conversion of cyanides into aldehydes. Now, let us discuss about the each and every reaction in detail. So, let us move to the Clemency reduction. So, what is the importance of Clemency reduction? It involves the reduction of carbonyl group into methylene group. So, what is the importance of Clemency reduction? It involves the conversion of carbonyl group into methylene group, and the reduction takes place in the presence of amalgamated zinc and HCl. Let us see few examples. So let us consider acetophenone. So whenever acetophenone treated with amalgamated zinc in the presence of HCl, what happens? This carbonyl group will be converted into methylene group. And hence, it results in the formation of ethyl benzene. So here acetophenone is converted into ethyl benzene when it is reduced in the presence of amalgamated zinc supported by HCl. In the similar way, alkyl aldehydes can also be converted into corresponding alkanes when reduced in the presence of amalgamated zinc and HCl. So here what happens? C double bond O group will be converted into methylene group. Then it results in the formation of, can you name this compound? Yes, it can be called as N-heptane. Simply what happens? The carbonyl group can be converted into methylene group. So not only aryl carbonyls or alkyl carbonates will be converted into corresponding alkanes, but it is also possible to convert cyclocarbonyls into corresponding cycloalkanes. Here what is the reagent used? Yes, it is amalgamated zinc in the presence of HCl. Is it clear about the Clemency reduction, students? Next, we will discuss about the Wolff-Kishner reduction. Here also what happens? Carbonyl group will be converted into methylene group, but here the reduction takes place in the presence of hydrazine and sodium hydroxide. Generally heating will be done. Okay, let us see two examples. Whenever if we consider diphenyl carbonyl compound, it undergoes reduction when it is treated with hydrazine in the presence of sodium hydroxide. Then what happens? The carbonyl group will be converted into methylene group. So we are going to get diphenyl methane. Is it clear, students? So whenever diphenyl ketone is treated with hydrazine in the presence of a base, it results in the formation of diphenyl methane. One of the most important application of Wolff-Kishner reduction is it is possible to reduce camphor into camphane. So what is the important application of Wolff-Kishner reduction, students? Camphor will be reduced to camphane when it is treated with hydrazine in the presence of alkali. High temperatures are supposed to be maintained. Clear? Here the carbonyl group is converted into methylene group. So it is possible to convert camphor into camphane by treating with hydrazine in the presence of a base. Is it clear about the Wolff-Kishner reduction, students? Next, we will discuss about the Zarrow reaction. So what is the present reaction? That is Zarrow reaction. So coming to the Zarrow reaction, especially the aldehydes without alpha hydrogen. Alpha hydrogens means, let us consider one example. So the importance of Zarrow reaction is, here two aldehydes will be taken or two carbonyl molecules will be taken. Then what happens? One undergoes reduction and the other one undergoes oxidation. So what is the importance of Zarrow reaction, students? Whenever if we consider two carbonyl molecules, one undergoes reduction and the other one undergoes oxidation. So here aldehydes undergoes self-oxidation and reduction when treated with alkali at high temperatures. Here one of the requirement is the carbonyl group is not supposed to contain alpha hydrogens. That means aldehydes like formaldehyde, aryl aldehydes undergoes Zarrow reaction. Let us consider one simple example. Whenever if we consider benzaldehyde, so it is not at all having any alpha hydrogens. So it undergoes Zarrow reaction. So two molecules of benzaldehyde. Let us see the structural formula of benzaldehyde. Here aldehyde is the functional group and it is called as, the adjacent carbon atom is called as alpha carbon atom, and the hydrogens present on the adjacent carbon atom are called as alpha hydrogens. Here no hydrogen will be present. So here benzaldehyde easily participates in Cannizzaro reaction. So what is the requirement for Cannizzaro reaction, students? Aldehydes without alpha hydrogen undergo self oxidation and reduction when treated with sodium hydroxide. Then what happens, students? One molecule undergoes reduction into corresponding alcohol and the other molecule undergoes oxidation into corresponding acid. And similarly, we can consider the reaction with formaldehyde. When we consider formaldehyde, it is not at all having any alpha carbon atom. So it also participates in Cannizzaro reaction. So what is the importance of Cannizzaro reaction, students? So whenever aldehydes devoid of alpha hydrogen treated with sodium hydroxide, then one molecule undergoes oxidation and the other molecule undergoes reduction. So we are going to get methanol plus sodium formate. Students, is it clear about the Cannizzaro reaction? Aldehydes devoid of alpha hydrogens undergoes self-oxidation and reduction when treated with alkali. Clear, students? Let us move on to the crossed Cannizzaro reaction. So what do you mean by crossed Cannizzaro reaction, students? That means here the reduction will be done with aryl aldehyde. So crossed Cannizzaro reaction means here we are going to consider aryl aldehyde and also formaldehyde. So we are taking two different aldehydes and we are treating with sodium hydroxide. Then what happens? One molecule undergoes oxidation whereas the other molecule undergoes reduction. Remember, students, always aryl aldehyde undergoes reduction whereas formaldehyde undergoes oxidation. Why? This formaldehyde is having greater probability to be attacked by a nucleophile. Thus, formaldehyde undergoes oxidation whereas benzaldehyde undergoes reduction. Is it clear, students, about the crossed Cannizzaro reaction? So, crossed Cannizzaro reaction means here benzaldehyde is treated with formaldehyde in the presence of sodium hydroxide. Then formaldehyde undergoes oxidation whereas benzaldehyde undergoes reduction. Next, we will discuss about the aldol condensation. Coming to the aldol condensation, especially the aldehydes which contains alpha hydrogen undergoes self-condensation. So that means we will consider a simple example. Let us consider two molecules of acetaldehyde. So here what is the requirement? It must contain alpha hydrogens. So the aldehydes which contains alpha hydrogen atoms undergoes self condensation in the presence of dilute alkali. With the result, what happens? It results in the formation of beta hydroxy aldehyde. Just condensation takes place. So here what happens? Carbonyl group will be present. Okay. So just condensation reaction takes place. Then what happens? It results in the formation of CH3, COH, CH, CH2, CHO. So here the functional group is aldehyde is the principal functional group. It is the alpha carbon atom and it is the beta carbon atom. Hydroxy is the substituent. So it will be called as beta hydroxy aldehyde. So what is the functional group? Aldehyde is the functional group. And what is the substituent? Alcohol. So it can be simply called as aldol. So this product is also called as aldol. So in aldol condensation, what happens, students? The aldehydes which contains alpha hydrogen undergoes self-condensation in the presence of dilute alkali and it results in the formation of beta hydroxy aldehyde. Is it clear about the aldol condensation, students? Next, we will discuss about the Rosemann reaction. And this reaction is highly useful for the preparation of benzaldehyde. So, let us consider an acid chloride. That means, let us consider benzoyl chloride, COCl, and it undergoes reduction in the presence of palladium and barium sulphate. So especially acid halides undergoes reduction in the presence of palladium and barium sulphate and it results in the formation of aldehyde. In this case, benzaldehyde can be prepared. Is it clear, students? And it is also possible to reduce alkyl acyl halides into corresponding aldehydes. That means when we consider an alkyl acid halide that can be reduced with palladium and barium sulphate. So it is acetyl chloride. It can be reduced in the presence of palladium and barium sulphate. Then it results in the formation of acetaldehyde. Is it clear, students? So here both aryl and alkyl acid halides can be reduced into corresponding aldehydes. That is about the Rosemann reaction. Next we will discuss about the Itard reaction. So Itard reaction means it is highly useful for the preparation of benzaldehyde by using toluene. So what is the starting material, students? Here toluene is used as the starting material. So when it is treated with chromyl chloride. So what is the reagent used here? Chromyl chloride. Then it results in the formation of benzaldehyde. Students, what is Itard reaction? In Itard reaction, toluene can be converted into benzaldehyde by treating with chromyl chloride. Next, we will discuss about the Zarrow-Koch reaction. So, what is the reaction? Zarrow-Koch reaction. Here, benzaldehyde can be prepared by using benzene. So, in this reaction, benzene is treated with carbon monoxide and HCl in the presence of anhydrous aluminium chloride and cuprous chloride. So whenever we use cuprous chloride at room temperature only the reaction takes place. So benzene on treatment with carbon monoxide and HCl in the presence of anhydrous AlCl3 and cuprous chloride, it results in the formation of benzaldehyde. And finally, we are going to discuss about the Stephen's reduction. So, Stephen's reduction generally involves the conversion of cyanide into the corresponding aldehyde. Let us consider a simple reaction. Let us consider alkyl cyanide. So, it undergoes reduction in the presence of stannous chloride and HCl, followed by the hydrolysis. Then it results in the formation of aldehyde. So in Stephen's reduction, what happens? The cyanide is reduced in the presence of stannous chloride and HCl, followed by the hydrolysis. Then it results in the formation of corresponding aldehyde. So here we can also prepare benzaldehyde simply by following Stephen's reduction. So we have to use the same reagents. Then what happens? This cyano group will be converted into corresponding aldehyde. So during Stephen's reduction also we can prepare benzaldehyde by using the corresponding cyanide. Is it clear, students? If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.